right, so today we're going to be figuring out what is x. And we're going to really encourage you to use the algebra today, even though some of them you can do the problems in your head. Like here for number 1, we could say 10 plus some number. Remember our box in elementary equals 12. And y'all be like, oh, the box is 2, therefore, okay, x is 2. And y'all can do that in your head. And then here we said 5 times some number equals 15, or 5 times your box equals 15, and you're like, oh, okay, x is 3. But then when we get here, if I said 4 times some number plus 5 is 29, it might take you a little bit more time, but you'd be able to figure out what x is without using any sort of algebra. But let's look at number 4 here. When you look at number 4, you're going to really need to use the steps given to you today in order to solve for x here. We are going to start by using simple algebra, and then we're going to go further and further into it. So today we're not going to just solve by just using or finding out what x is. We're going to use the algebra that's used behind it. Okay, so here in 6th grade, it shows you where it's very simple. 7th grade gets a little bit harder. Here's 8th grade, and then it takes you all the way to algebra. So we're going to make sure we're going to use those algebraic steps today. Okay? All right. So step 1, we're going to look for x. What units are with it? Okay? Step 2, we're going to make 0 pairs on the side with x to isolate it. And then step 3, we're going to add the exact same units to the other side. Determine the value, and that's going to be our answer. Okay, so our goal here is to get n all by itself. Okay, we want to get the letter all by itself. So what's on the side with n? We don't want anything with n. N is telling this 2 to go away. The only way you're going to get rid of a positive 2 is by adding a negative 2. Okay? A positive and a negative get rid of each other. But remember, what you do to one side, you have to do the exact same thing to the other side. So if you are subtracting 2 from this side to get rid of 2 because n wants to be all by itself, then you have to subtract 2 to this side. Okay? So positive 2 and negative 2, they're gone. They went bye-bye. Okay, all we have is n all by itself. It's what n wanted to begin with. N doesn't want to be with anybody. Okay? And then now on this side, we have 6 take away 2. And we know that 6 take away 2 is 4. Therefore, we know that our solution would be n equals 4. Okay? Let's try another one here. Remember, the letter always wants to be all by itself. So x here wants to be all by itself. So who's got to get lost? 6 has to get lost, right? And this isn't just any kind of 6, it's a negative 6. And the only thing that gets rid of a negative 6 is its opposite. So the opposite of a negative 6 is a positive 6. Remember the pirates and the ninjas? If you have 6 pirates and 6 ninjas, they're gone, right? But what you do to one side, you have to do the exact same thing to the other side. So if you're going to add 6 to this side, you now have to add 6 to the other side. Okay? That's what keeps it balanced. That's what keeps everything going, right? So now these 6's are gone. X is now all by itself. Remember, the letter always wants to be by itself. And now we have 12 negatives and 6 positives. Okay? So because I have opposite signs, I'm really subtracting. So 12 take away 6 is 6. And because I have more negatives than I do positives, this would be a negative 6. So my solution here is x equals negative 6. All right, let's try that again. Oh, look. The number doesn't always have to be on this side. It can always be on the other side too. But remember, who wants to be alone? The letter, the variable, always wants to be alone. So I want y. Y wants to be all by itself. So who needs to get lost? Well, positive 2 needs to get lost, right? So the only way to get rid of a positive 2 is by adding a negative 2. So if I add a negative 2 to this side, that means I have to do the exact same thing to the other side and add a negative 2, okay? Remember, the letter wants to be all by itself. It does not matter which side the letter is on. So positive 2 got lost. If it switches over to the other side, so now we have 6 minus 2, which is 4. So the value of y is 4. So we have 4 equals y is our answer here. Okay, let's try that again. All right, again, who wants to be by itself? Remember, the letter wants to be all by itself. So x wants to be all alone. So who needs to get lost? Negative 9 needs to get lost. How are we going to get rid of negative 9? Well, the opposite of a negative 9 is a positive 9. Remember, you want opposites here. So if I add 9 to this side, that means I now have to add 9 to the other side. Okay, a negative 9 and a positive 9, they get rid of each other. You now have x all by itself. And then 12 plus 9 is 20. So my final, sorry, not 20, just kidding, I know how to add. It's 21. See how my answer choices guided me? I'm like, oops, I added incorrectly. Okay, so 21 equals x is my final answer. All right. Oh, look, the letter is always by itself. Remember, you're looking for the letter. So I found y. Y is all by its, we want y all by itself. So who needs to get lost, right? This positive 7 here needs to get lost. So what is the opposite of a positive 7? A negative 7, right? If I add negative 7 to this side, I now have to add negative 7 to this side. All right, so a positive 7 and a negative 7, they get rid of each other. We now only have y left on this side. And remember, a negative 9 and a negative 7, they are the same sign, so we're really going to add 9 plus 7, which is 16. And then because they're both negatives, we want to keep them negatives. So my answer here is y equals negative 16. So I'm going to go ahead and put my y equals negative 16 here. All right, again, who wants to be all by itself? N wants to be by itself, right? The letter always wants to be alone. Who needs to get lost? Positive 3. So what's the opposite of a positive 3? A negative 3. So what I do to one side, I now have to do to the other side. So we have positive 3 and negative 3 cancel each other out. And remember, a negative 7 and a negative 3, same sign, so we're going to add and keep the sign. That would be n equals negative 10. Okay? All right. Again, who wants to be all by itself? The letter does. Who needs to get lost? The positive 5 needs to get lost. Remember, the number with the letter always needs to get lost. So you want to do to both sides the opposite of that number. So what is the opposite of a positive 5? A negative 5. So that means we're going to put negative 5 on both sides of the equal sign. Okay? So we're just going to have x over here on this side now because a positive 5 and a negative 5 are gone. And a negative 4 and a negative 5 make a negative 9. Therefore, negative 9 equals x. All right, last one. Again, we're going to locate that variable, that letter, because this is what wants to be alone. Who needs to get lost? Negative 3 needs to get lost, right? So the opposite of a negative 3 is a positive 3. So if we add 3 to this side, we now have to add 3 to this side. Remember, a negative and a positive of the same number cancel each other out, which is exactly what we wanted because n wants to be alone. And then a negative 15 and a positive 3, they're opposites, so we subtract. 15 take away 3 is 12. And because I have more negatives than I do positives, this 12 should be a negative. So n equals negative 12 should be my answer.